All right, now I'm going to be covering Chapter 2 overview, equations, inequalities, problem solving, as this relates to an intermediate algebra course. Because this is a review, I will be going quickly. If you need to review something, even more so, please pause, go back, replay, take a look at some things. Also, because it is a review, recognize too, I can't cover every aspect in detail. Further information definitely can be found inside of a textbook, reading what authors have written, which is extensive in terms of portions of and applications of some of the problems we're going through today. This one, straight up simple one variable equation, solving this for x. Order of operations, really, when I teach this originally to much lower levels, I say, look at what we're solving for x. That's the center of my onion, if you will. You need to peel back the layers to finally get at x. So you always start with what's on the outside, what's furthest away from the x to solve. And again, solving an equation means that there's an equal sign in there. So at the very end, I need to have x equals something. So on the left-hand side, I look at what's furthest away from the x, and that's the -2. And I am always thinking of inverse operations. What is the inverse of subtracting 2? The inverse of subtracting 2 is adding 2. And because an equal sign is a balance, in order to tip the scale of that balance, so as to not to tip the scale of that balance, whatever goes on one side of the equation has to go on the other side of an equation. So it has to be the identical thing going on both sides of an equation. Otherwise, we'll have an imbalance and we'll no longer have an equality. So -2, +2, they add to 0. I'm left with -3x on the left. I'm left with, it's now 12 on the right. And I just brought them straight down as well. Helps me to keep my lines and systems organized. And then I look and see that I have a -3x. And I say, all right, operation going on between those is multiplying. The inverse of multiplying is dividing. So I'm going to then divide both sides by -3. Do exactly one side to the other. -3 divided by -3 is 1. I'm left with 1x. And then 12 divided by -3 is -4. A good process, though, is to always go back and check and plug that in up there to see if it definitely works or not. So I'd say -3 times -4, because that's my x. -3 times -4, negative, positive 12 minus 2 is 10. It checks. When we get to bigger questions like this, and we see lots of fractions, people get worried about fractions. I say, if there's anything I can do to eliminate fractions, I'm going to do that. So what I'm going to do is look and say, what are the denominators of all of these portions? All right, although it's not written there, it's 1. So my denominators are 1, 6, 3, and 3. And I want to look for what is the lowest common denominator. What's the one thing I could do that they all have? So there'll be the lowest common denominator. That is, what will 1 go into, 6 go into, and 3 go into? They will all go into 6. So I'm going to multiply absolutely everything by 6. And when I do that, I'll then have 6x over 1 minus 6 times x minus 2 over 6 equals 6 times x minus, that's a 7, over 3, plus 6 times 2 over 3. This carries down, that's just 6x minus, here I'll have the negative, this 6 and that 6, since I have multiplying only on the top, I have this and this factor multiplying, the parenthesis times a 6. These can reduce, leaving me with x minus 2. On the right side, I have the 6 and the 3. They will reduce to 2, x minus 7, plus, and they're the 6 and the 3 reduced to 2 as well, so it'll be 2 times 2. I'm going to keep working here, 6x. Then I'm going to distribute this negative into, so I can get rid of the parentheses, so -x plus 2 equals, going to distribute that 2 in, 2x minus 14 plus 4. On the left-hand side, I have 6x minus x, so I have 5x's plus 2 equals 2x minus 10. Negative 14 plus 4 is 10. Now I need to move, because again, ultimately at the end, I want to get my x's all the way on one side and my numbers on the other. So I will subtract 2x from both sides. And I'm going to double this up. I'm going to subtract 2 from both sides. I can put my equal sign here as well, because these are identical things. Negative 2x minus 2, negative 2x minus 2 are the same. So that way, when I finish up that arithmetic, I'll have 3x equals negative 12 divide by 3, x equals negative 4. It would be a good idea for you to pause the video right now, go back in there, and check to see if that solution does indeed work. If it does, then we did the work correctly. If it doesn't, well, I can tell you what, we did the work correctly. So if you put the negative 4 in and you get something and you don't get these two to be identical numbers on each side of the equal sign, then you did something wrong in your arithmetic, but we did do that correctly. More of the same. What I want you to do here is I want you to go ahead and solve this equation and then hit pause, hit pause, then solve this equation, and then come back to see if you got the right answer. Carrying on from here, we can see 12x equals 12x. If you've worked this out the same way, and then you would finally say, all right, well, I'm going to divide both sides by 12. I'll have x equals x, which actually, if I go back to this line and do it a different way, subtract 12x from both sides. So if I do 12x equals 12x, get all x's to one side, we end up with 0 equals 0. And we say, well, how often does 0 equal 0? And the answer is it always equals 0. So that means you can do anything. Any number works. Put in any number into that equation, and you will get a solution that you end up with the same numbers on both sides. So that means my solution is all real numbers. Sometimes it's written as negative infinity to positive infinity. Or you can just say the words all real numbers. Then sometimes we're asked to solve an equation where it's not necessarily going to give us a numeric answer. Here I have a formula, and I need to solve for r. So again, looking at r, I need to peel back the layers. The first thing I need to get rid of that's furthest away from the r is the p. And p right here is being multiplied, so I'm going to divide both sides by p. I will have a over p equals 1 plus r squared. I can't do anything with that 1 yet because it's trapped inside the parentheses, and the parentheses are trapping it with the squaring. So I'm thinking, again, inverse operations. What's the inverse of squaring? And the answer is the square root. So then I'm left with the square root of a over p equals 1 plus r. And now to solve for r, I move over the 1. So I end up with r equals the square root of a over p plus 1. Notice how I make a very distinct plus 1 outside, away from the radical and the root sign, so that you don't get confused and think that it's underneath the square root sign. We're going to solve these in graph. Now we have inequalities, but our processes stay the same. Inverse of 3 times x is 3 divided by 3. Over here, divided by 3, I have x less than 1/3. I'm going to graph that. I have one variable, so I have a number line only. My boundary point is 1/3, and I need x less than 1/3. Where is x less than 1/3 on that graph? It will be to the left of 1/3. And I'm not including 1/3 because it's just less than, so it's not less than or equal to. So in a graph like this, we do an open dot. If I was doing this in set notation, I would say that I'm going from negative infinity up to 1/3, and then open parentheses. If it were less than or equal to, it would be a bracket. So let's actually change this next one to be greater than or equal to. And now we're going to go, same kind of thing, inverse operations, divide by -3, and here's where a very special rule comes into place that I'm not going to derive for you, but when you divide or multiply both sides by a negative number, because we're switching the sign, we are going to switch the direction of the inequality sign as well. I'll have x greater than or equal to 1/3. I have a number line. My boundary point is negative 1/3. I now have a equal sign, so it can be equal to 1/3. So it's a shaded in dot. And then to the right, set notation would be bracket negative 1/3 as my lower end, comma, upper end is positive infinity. So here we go. Do you like fractions or not? If you don't, we're going to multiply everything by my common denominator. There is only one denominator. Going to multiply everything by 7 and then do distributive property in. I'll be left with 3 parentheses x minus 4 greater than or equal to 7x plus 14, 3x minus 12 greater than or equal to 7x plus 14. I'm going to move everything to the right-hand side for my x's, so minus 3x to both sides. And then I'm going to subtract 14 from both sides, so I'm doing the identical thing to both sides of this equation. On the left-hand side, I have now negative 26 greater than or equal to 4x. And if I'm doing my work correctly, then divide by 4, and x will be negative, let's see, 4.5, 6, sorry about that. Doing this on the fly here, folks. 6.5, or 13 halves. Number line, negative 6.5. Gonna make my dot. It is equal to, and then where is my x? Even though it's on the right-hand side, so I gotta look, x is less than, or 6, this is greater than that number, so I'm shading on my number line to the left. X, so I'm gonna add 7, x will be less than or equal to 11, x greater than or equal to negative 21. It says and, so I'm going to look at a number line. I've got two numbers now. I'm at negative 21. I'm at positive 11. And this first equation tells me x is less than 11, which means it will be from 11, close dot, to the left. The second equation says x is greater than or equal to negative 21. So that will be at negative 21, greater than or equal to is a closed dot, and is greater than or equal to, so it is going that way. So the question is, and where are both of them true? In order to be and, both of them are true on this interval, because that's where both of the lines are. So my interval goes from negative 21, bracket, because it includes 21, comma 11, bracket. You could also say, using more of a mathematical notation, x is, let me move it this way, negative 21 less than or equal to x less than or equal to 11. Now we're going to do absolute values. Same kind of thing. We need to get it separated out, so I only have one equation on the left-hand side with just the absolute value. Going to subtract 6, so I'm going to have absolute value of 3x minus 2 equals 4. And then what I have to do is I have to be thinking to myself, absolute value of what number is 4? And the answer is it's either 4 or negative 4. So when I have an absolute value, I'm actually splitting it into two equations. 3x minus 2, when does that equal negative 4? When does 3x minus 2 equal 4? And that would be 3x equaling negative 2, because I added 2, x equaling negative 2/3. Over here, 3x equaling 6, because I added 2, so x would equal 2. And the answer here then would be or, because you can't be two things at the same time. Using some set notation, I would have x equals negative 2/3, or, that's a union symbol, x equals 2. This is a union, a giant U. It's translated as the word or. You can just use the word or. I'm good with that. Now we have an inequality, same idea, but here what we do is we extend it and we put the inequality same direction on the other side, change it to a 1. 6x minus 5 greater than or equal to -1, and then we'll go ahead and split them up and solve them. Again, because it's the absolute value, it's going to be the positive or the negative version of that. So I have 1 greater than or equal to 6x minus 5. On the other side, 6x minus 5 less than, sorry, wrong direction, greater than or equal to 1, -1. Keep track of my negatives. Solve the equation on the left. I'm going to add 5. I have 6, that's an adding by the way, greater than or equal to 6x, x 1, because I divided both sides by 1. And then on the right hand side, I'm going to have 6x greater than or equal to 4, because I added 5 to both sides. X greater than or equal to 2/3. I have the number 2/3. I have the number 1. And I am going to put open dots. So x is greater than 2/3, so I'm going to shade up. This one is x less than 1. It's going to shade down. So my solution will be x is less, let's see, x is greater than or equal to 2/3, less than or equal to 1. Try it the other way around, same idea. -1 less than or equal to 6x minus 5, 6x minus 5 less than or equal to -1, 6x greater than or equal to 4, x greater than or equal to 2/3. Over here, add 5, 6x less than or equal to 4. Did I do something wrong? Nope. All right. X less than or equal to 2/3. Oh, I know what I did. Made a mistake here, folks. Bear with me. Here, this should be a +1 on the left-hand side. That's a +1. That makes this a 6. And that makes that a 1. I still got my numbers of 2/3 and 1. This one, x greater than 1. 1 up and over that way. Second equation, x less than -2/3. It goes to the left. So in this case, it will only work if I have a number that is both greater than 1 and less than 2/3, which means there is no number that makes both this true and that true, because if I'm greater than 1, I cannot also be less than 2/3. So in this case, there is no solution to this equation. Empty set, no solution. There is no number that when you put it in there, it's less than -1. Now you could look at this intuitively and say, well, absolute value means whatever's inside here is always positive. What positive number is less than -1? And the answer is there isn't one. Well, there you go. That's a quick overview and review of Chapter 2.